Hi, good morning. So we're going to be going through solving two-step equations today. So that's just an extension on one-step equation, but it does involve a little bit more process. So just running through some vocabulary review. We have expressions and then we have equations. Expressions are just a collection of numbers and symbols that represent a quantity. They do not have an equal sign, where equations are a statement of two expressions being equal to each other. You can think of an expression as half of an equation, either what's on the left or the right. But an equation becomes an equation once it has an equal sign on it. Now, in order to solve equations, we're going to be using these inverse operations, which are operations that undo something that was performed. So, for example, the opposite of addition is subtraction, the opposite of multiplication is division, and vice versa. You guys should be very well versed with this image. I've used it a couple of times, and it just gives you some general ideas of how you can use inverse operations in order to undo operation. So back to this golden rule of algebra, we could think of it solving equations like a scale. We want to start balance and we have to end balance. So if, for example, if I take away values from the left side, I have to add it to the right side in order for these pans to stay balanced. We cannot determine that an equation is solved correctly unless we're treating both sides of the equation evenly. Okay, so this is how you guys were solving one-step equations. So we would have, for example, 5x equals 25. The first thing you would do is identify the operation, which is multiplication. Then what you would do is you would identify the opposite operation, which is division. You would perform that operation on both sides of your equation and then identify your solution. So here's the work. I have 5x equals 25. I'm dividing by 5, which is what we're indicating in step 2. And then we're solving out. We have 5 divided by 5 is 1. We don't have to write a 1 here because it is assumed that if we have just a solo x, it is one of them. And then we have 25 divided by 5 is 5. Okay, and now solving two-step equations. These are a little bit more work because there is more operations inherently happening inside of this equation. Now, because of the way the world works, when we have multiple operations, we have a process called order of operations. So we have to make sure that we are following that order in order to evaluate expressions. So that's no different, that we're going to have an order that we need to follow when we are solving equations. And that order is something you should be a little bit familiar with, but you have to think about it in a little bit of a different way. So because we have multiple operations, we have to think about the order in which we are actually undoing them. Now, inverse operations, if you work your way backwards, that's the way that we're going to be solving for our missing variables here. So remember, when you're evaluating, you're completing PEMDAS from left to right, which is multiplying and dividing first, and then adding and subtracting second. But when we are solving equations, we're going to be doing this process backwards. So we're generally going to be adding and subtracting first, and then multiplying and dividing second. The reason for this is because we're trying to find that variable, and that variable, if it is being multiplied, it has to be divided out last. So for example, which you'll see in the next couple of slides, we need to start solving for all the things around the variable rather than starting with the variable itself. Okay, so you have to think about this as retracing your steps. So basically going backwards. If we had to multiply and divide to get to my particular endpoint, we need to divide in order to get back to my beginning. So we are just retracing our steps. So I'm going to leave this graphic in the corner so that way we could look at it and reference it. So we have 5x plus 10 equals 20. We are going to be identifying these operations that are happening first. We have multiplication because I have a 5x here, and then I have a plus 10, which is addition. We're going to find these inverse operations. I have division and subtraction. Opposite of multiplication is division. Opposite of addition is subtraction. Then I'm going to be looking at my diagram. I'm going backwards. So I'm looking for whichever comes farthest to the right. So I have subtraction is farthest to the right. So that's what I'm going to start with. Now I'm going to perform these operations. I have 5x plus 10 equals 20. I'm going to subtract 10. I have 5x equals 10 now. Remember, I don't have to write this 0 because positive 10 plus negative 10 is 0. So I have 5x equals 10. I'm going to divide by 5 on both sides. And I end up getting x equals 2. My last step is to identify my solution. Okay, and then we're going to keep going. So I'm going to keep that in the corner. I have 4x minus 8 equals 4. So I'm identifying the operations that are happening in the equation. So I have multiplication and subtraction. I have a 4x, which is a multiplication. And then I have a minus 8, which is a subtraction. I'm going to identify the inverses, which are division and addition. I know that I'm going to be adding first because that's the farthest right in my PEMDAS abbreviation. So I'm not subtracting. I am adding. So that means I have to perform this first if I'm going backwards. I'm going to perform the operations. So I'm adding 8 on both sides. I get 4x equals 12. I'm dividing by 4 on both sides. I get x equals 3. And then I'm identifying my solution of x equals 3. Please be advised you do not have to write that 1. I have 4 divided by 4 is 1. 1x is assumed if it is just written by itself. It is just 1. Okay. Last one. We're going to be doing something a little backwards right now. So I have 10 minus 3x equals 1. These operations that are happening right here are multiplication and addition. Now, this multiplication here is by a negative 3. And this addition here is just because I have a 10 on the end. Now, the big thing here is we assume that this 10 is positive, which is why the operation that I'm doing is addition. That's why the operation I'm doing is addition. So the opposite to here would be division and subtraction. I'm going to look on my diagram to see which is the farthest right. That's subtraction. So that means I'm going to do that first. What is there to subtract? I can subtract this 10. I can subtract this 10 out. Okay, so that's what I'm going to do. I'm going to subtract that 10. Remember the 10 is positive. There's no sign to it to the left. There's no positive or negative. So we assume that it's positive. And now I'm going to be left with negative 3x is equal to negative 9. And remember to pay attention to the negative in front of that 3. That's a negative 3 right here. And then I'm going to go ahead and divide by my negative 3. So negative 3 divided by negative 3 is a positive 1. So remember, we don't need to write that in my final answer. And then I have negative 9 divided by negative 3, which is positive 3. And then I'm going to identify my solution clearly that it's a positive 3. Now, if you're just a little confused, always make sure that you check your work at the end. So you could take this answer and plug it back in and do regular left to right PEMDAS. So I have 3. I plug it back into my equation. 10 minus 3 times 3. I'm going to multiply first. So 3 times 3 is 9. Then subtract second. 10 minus 9 is 1. And that checks out. Thank you guys so much for tuning in. Please, please, please feel free to send myself or Miss Burton some emails, Google Hangouts, Zoom chats, asking some questions, comments, concerns, issues. Please stay safe and let us know if you have any questions. Thanks so much.